Okay guys, so I filmed this video yesterday and all you could hear was like all the tap tap taps of the Apple Pencil. So I'm gonna try, I'm using headphones this time with a mic like up by my mouth, not just the iPad mic. So hopefully that cuts some of it and I'll try and write a little lighter. But I promised you guys this video, so I wanted to do it over and hopefully it's better this time. So Tracy wants to buy some pies for her sisters, and she has a budget of $82 to spend on 5 apples, $5 apple pies, $4.50 banana pies, $5.50 chocolate pies. She wants to buy 16 pies for her sisters and must buy as many chocolate pies as apple pies and banana pies combined. How many of each item should she buy? Write a system of equations to help you solve this. So our first step when we're solving a system of equations is to identify our variables and label them. I'm going to use X, Y, Z because I'm most comfortable solving with X, Y, Z, right? I don't, it's sometimes if you use like B for banana pie, sometimes people think those are 6s and start to confuse themselves. So I like to stick to X, Y, Z. You can use whatever variables you want so long as you define them. So X, Y, and Z, and we need to be specific when we're labeling our variables, right? I can't just say X is chocolate pies. Does that mean that X is the number of chocolate pies you bought? Is it the cost of a chocolate pie? Is it the percent chocolate in a chocolate pie, right? So we're going to say that X is the number of chocolate pies. And I think I have this, oops. We'll just, we'll put this on the end so that we don't have to rewrite it. We'll say that Y is the number of banana pies that Tracy buys, and Z would therefore be the number of apple pies that Tracy buys. So now we can go ahead and set up our equations. We're going to take each sentence and turn it into an equation. So first we have that she has a budget of $82, okay, to spend on $5 apple pies, $4.50 banana pies, and $5.50 chocolate pies. Okay, so we learned in class the other day that if you have the price of an item, the price of the item times the number of items is going to equal the total price for that. So $5 times X, since, or Z it would be, I don't know why I labeled backwards. $5 times Z, if I bought 3 apple pies, it would be $5 times 3, which is $15. So 5Z and 450Y plus 550X, that's going to be our total cost, and we want to spend $82. So we'll set it equal to 82. The next sentence, well, we can actually get two equations from this sentence. The first part says she wants to buy 16 pies. She wants to buy 16 pies total. So say this little 4x4 grid here is the, oh, I don't know why that went curvy. This little 4x4 grid here is how many pies she wants to buy. The total number is 16. Say this many is banana, that's your X. This many is, chocolate, or that's your X. Banana is your Y, and then here is your Z. So Z plus Y plus X, I don't really know if that image helped, but basically if X, Y, and Z are your number of pies of each pie, and you want 16 pies total, the number of chocolate pies plus the number of banana pies plus the number of apple pies would equal the total number of pies, which is 16. And then the last part says she must buy as many chocolate pies as apple and banana pies combined. So let's just think of this in words. If I bought 10 chocolate pies, that would mean that I would need 10 banana and apple pies. It doesn't specify, an equal number of banana and apple pies. It could be 9 banana and one apple pie, but if I'm doing 10 chocolate pies, and that's x, so 10 chocolate pies must be equal to the banana and apple pies combined. So that's that equation. Okay, and now we have 3 equations and 3 unknowns. So this linear system is something that I can solve. So first step, identify your variables, and I'm going to recenter this because it's bothering me. Then, once you have your variables, create a system of equations, and now we just solve it. Now we're going back to learning target 3, solving a system of 3 variables and 3 unknowns. So I'm going to label these. We're going to call this 1, 2, and 3. Actually, let's make it A, B, C. Probably easier to keep track of. We'll call this A, B, and C. And remember, we need to eliminate the same variable twice. So the first thing I'm going to do is I'm going to eliminate x by substituting. I'm going to use substitution because notice equation C is already solved for x. So I'm going to substitute equation C into equation B. Since I know that x is equal to, since x equals y plus z, I can take equation B, which is z plus y plus x, and I can replace x with y plus z. So it'll become z plus y plus z equals 16, and that's going to simplify to z plus z is 2z, y plus y is 2y, equals 16. Okay, so now I've eliminated x once. I need to eliminate x again, and I have 2 options. I can either eliminate x using A and B or A and C. So you could substitute x in, you could use substitution again, but for the sake of practicing multiple ways, I'm going to use elimination. And I'm going to use equations A and B. So in order to eliminate with A and B, I need to make 5.5x and x a 0 pair. And the way that I would do that is by multiplying x by negative 5.5. So what that's going to look like is I have to multiply the entire equation. I have to multiply the entire equation B by negative 5.5. Because that's how I'm going to turn this into a 0 pair, which is what I need to be able to eliminate it. So A is 5z plus 4.5y plus 5.5x equals 82. Negative 5.5 times B, well, all the coefficients are just going to become negative 5.5. Negative 5.5z minus 5.5y minus 5.5x equals, I don't know that off the top of my head, 16 times negative 5.5 is negative 88. So negative 88. And now, because I have these set up in the same order, I can simply add them, right, like we did in Learning Target 3. Add straight down. That's not a straight line. Add straight down. 5z minus 5.5 is going to be negative 0.5z. 4.5y plus negative 5.5y is going to be just 1y, negative 1y. And then this is a 0 pair. That's what we wanted to happen. 82 plus negative 88 is negative 6. Now, since I eliminated x twice, I have a system of 2 equations and 2 unknowns, right? 2z plus 2y equals 16. Negative 0.5z minus y equals negative 6. And this is back to Algebra 1, or back to Unit 4 Learning Target 1, right? I've got a system of 2 equations and 2 unknowns. And I'm going to call this equation D and this equation E. And I'm going to use elimination here because I can see pretty easily that if I take equation E and I multiply it by 2, I'm going to create a 0 pair here. If I multiply equation E by 2, the y's will cancel out. You could use substitution here. You could multiply the z's by 4. and it would work as well. So I'm going to take equation D, 2z plus 2y equals 16. And then equation E, I'm going to multiply it by 2. 2 times negative 0.5 is just negative 1. So negative z minus 2y equals negative 12. And then I'll just add straight down, right? Add straight down. 2z plus negative z is z. These two will cancel, and then we'll get z equals 4. And then once we know that z equals 4, we can waterfall to find all of the other variables. So z equals 4, we can then plug it in to either of these equations, since we know that z is 4, to solve for y. I'll plug it into the bottom one. So negative 0.5 z minus y equals negative 6, but again, we know z is 4. So negative 0.5 times 4 minus y equals negative 6. Okay, negative 0.5 times 4 is going to be negative 2 minus y equals negative 6. Add 2 to both sides, negative y equals negative 4. That means that y equals 4. And then, right, y equals 4. Now we know that y is 4 and x is 4. We can use equation C that's already solved for x to find x. You could use A or B, but it's most definitely going to be easier to use equation C because we already know that x equals y plus z, but we know that y is 4 and z is 4. So x equals 4 plus 4. X is going to equal 8. So our final answer would be that Tracy will buy 8 chocolate pies, 4 banana pies, and 4 apple pies. And we're done. There's all the work. So you identify your equations by looking at what the question is asking for. That's what your variables normally become. Then you use the sentences to create 3 equations with 3 unknowns. Then you just solve them algebraically, and you're done.